Thank you very much. So I tried yesterday, but Shripad disappeared. So I'm trying this time again. So I think we should all thank Shripad for organizing this meeting in India. I would like to thank you all for your hospitality. And I think Shripad really, it's the best metronomic meeting so far. So congratulations. So let's go. So what I would like to show you, to talk about today are about phase 1 and phase 2 trial that we have in our French Society of Pediatric Oncology and Hematology. So it's, there's one phase 1, one phase 2 trial, and something that are odd things that are going on. So before I start, I have some potential conflicts of interest to declare, but I don't think they will impact on my talk. So I will start with the Fluvabreg study, which is a phase 1 trial based on pure drug repositioning. Then I will continue with the Metro SF001. So the data are not fully mature yet, but it's close to it. And then and I will end up with a project that shall be starting soon. So the Fluvabreg trial start with some data that were generated not long ago, but several years ago by a lab in our institution led by Dominique Figueras-Labranger. So at the time, what we were trying to understand is the difference between the different low-grade glioma depending on the localization. And so they differentiated cerebellar pilastic astrocytoma and those who were in the optical pathway. And they were able to identify some genes that were highly differentially expressed in those two different localizations. So these are the main genes. And so at the time we looked for the drugs in any kind of drug, like could be anti-cancer agent, could be target therapy, could be drug repositioning that could impact on these genes. And so what we found is that, among the drugs that could impact on these genes, some were really available. So the statin, we could find the statin for 3 of these genes, and cox inhibitors for another target. So since these drugs were available, they were already combined in all patients that could have, high cholesterol and also pain for a reason or another. We decided that we should try to go for these 2 drugs. We didn't need any pharma company to give us the authorization to do it. So then we looked in the literature. There were already available data that could help us or strengthen the rationale. And there was actually a paper that probably no one read or saw, because it was published in fairly unknown journal, and it was kind of old. It was published like almost 20 years ago, and it was about determining the MTD of fluvastatin in pediatric cancer patients. So it was like a standard phase 1 trial. And the interesting thing is that among the patients that had a stabilized disease, there were patients with anaplastic astrocytoma. The drug was fairly well tolerated, and it could increase the dosage 4 times as compared to what we usually use to lower cholesterol. And the funny thing is, there were no changes in cholesterol in the patient here. So that was our first step. Then we went through the literature, and there's also lots of data on both drugs and the potential impact on high-grade and low-grade glioma, mostly high-grade glioma. So I won't go through the details, but also what was interesting for us, there were also data in pediatric patients. So basically knew that we could give them safely in patients. And we thought we wouldn't have to go through the phase 1 trial. So then, to strengthen the rationale, we did a little work in the lab. We investigated if these 2 drugs had activity in vitro first. So we start with high-grade glioma cell lines, because there are no low-grade glioma that are really available to test the drugs. And so we were able to demonstrate that these drugs have activity, direct cytotoxic activity on the cell lines, that if you put the 2 together, you obtain a synergy. Well, that's terrible. I don't know what happened here. So basically, you also induce apoptosis when you use these T drugs. And we also did some experiments on low-grade glioma explants So when a kid was undergoing surgery, we just like put it in culture, and then we would test the drugs, and I don't know why it's all just messed up like that, sorry. And we were able to demonstrate that on these low-grade glioma explains both drug activity, and he also had a synergy on the tumor explains. So that was a nice rationale. And then we had the opportunity to test a very first patient that had a refractory metastatic high-grade hypochiasmatic low-grade glioma. You see, she received several lines of treatment, and that patient lives on a little island in the south of France called Corsica. And those patients they hate leaving the island. And the mother was alone, so she wouldn't want to come back and forth from the hospital. She had just had a new job. And so she wanted something oral, and she didn't want to go for radiotherapy because she was afraid of malignant transformation. So we proposed her. There was no emergency to treat her, but she was progressing. So we told her, well, if you want, we can try these 2 drugs. It's not a trial, it's very experimental, but we have some data, and so it should be really safe. So if you really, we had a good relationship, so we think we could do that. If ever it doesn't work, or if ever it's toxic, of course we stop, and we'll have to go to standard treatment. And you have to take the planes and do with your job and so on. And the good thing is that over the 18 months, you see you got the contrast enhancements in the middle, and you see that over 18 months it decreased really nicely. So the patient had no symptom basically, so it's hard to say that there was a clinical benefit. And sometimes this patient can regress spontaneously, so we can't really say for sure that the treatment induced the response, but that was a first nice signal. And so then we decided to go for a phase 1 trial. So the project is being, the responsible for the project is Dr. Pierre Leblanc at the Anti-Cancer Center in Lille. So, and all the pediatric oncologists in France, like for them it was really weird to go for non-cancer treatment for potentially high-grade and low-grade glioma, and they thought that could be dangerous. So we still had to go through the phase 1 trial. So we'll see later if it was a good or bad idea. So there was actually a first stage in which we were trying to find the MTD of the combination of 2 drugs, and then a second stage in where we recruit more patients to secure the recommended dose and eventually start having signal of activity. So we first, because the basic data in the beginning were really about differential signature between the localization of the low grade. So we wanted to recruit only low grade glioma, and we quickly amended the protocol to have also high grade glioma based on problem of recruitment, because there were several low grade glioma studies in France at the time, and there was a lot of competition, and there was nothing for high grade glioma, and there's some rationale for this combination. So the dose escalation method was based on a continual reassessment method. So you basically have 2 patients per level, and then depending on the occurrence of toxicity or not, you go to the next level. And if there's a toxicity, the model just calculate the risk of additional TLT, and you put some more patients. So it was kind of hard to get money for that trial, but we were, in the end of the day, fairly successful, because we had a national grant from the ANCA, we had some support from the Anti-Cancer Fund, and we had some support also from our national, Pediatric Oncology Society. So this is the treatment that we were planning to give. So there was fixed dose of celecoxib according to the weight, which are pretty standard, and we wanted to increase the dosage of prevastatin starting from the standard dose and going to the recommended dose that were determined by the previous pediatric study. So of course we were doing PK of both drug, and we also amended the protocol to lower the inclusion criteria for the age. So we have 10 patients recruited so far, which is at the same time within 2 years. So it's kind of slow, but it's good, because at the very beginning, physicians were really reluctant to give this drug repositioning and non-chemo and no-target therapy to these patients when they were relapsing. So we have mostly high-grade glioma, glioblastoma, glioblastomatosis, anaplastic glioma, ganglioma. The median age is 2.5 years old. We have 7 males, 3 females. And we overall, I'm not going through the details of going up and down in those levels, but we had 4 patients at level 1. The very first one was an obese patient, so we said like we're not going to take into consideration this patient for studying toxicity, because I mean we don't really know since he's obese. We went for the standard weight doses, so maybe he was underdosed. So we replaced them. And there were basically no DLT at this level. Then we have 5 patients at the second level with 1 DLT, and 1 patient was not available because at the end of the day he could not swallow the pill. So it was taken off the study. And then we had 1 patient at level 3 and we had DLT. So we are currently, we still need 1 patient to secure the level 2 of the doses. So we had some toxicities, 2 grade 4, some grade 3, but all these are very, very likely to tumor progression. So globally, most of the toxicity were mild, and except for 1 headache that was clearly not related to the treatment is pretty safe. Regarding outcome, out of the 10 patients, 7 have already stopped the treatment because of progression for 6 and because of toxicity for 1. 3 are still ongoing. These 10 patients received 43 cycles, so it's not too bad. These are 1-month cycles, so as most of the patients have high-grade glioma, it's not too bad. And it ranges from 1 to 18. The one with 18 is a patient with low-grade glioma who had a really refractory disease, because she received pretty much all the treatment before that are available. So that was a good news. So 7 patients had a stable disease after the endpoint for efficacy for activity, which was 2 cycles. And I think 2 patients had 4 cycles or more. So this is where we are. So we need 1 more patient to secure the level. We haven't done the PK yet to see if we have some interaction. And the question now is, are we going to open the extension cohort for low-grade glioma only, or should we go for the 2 tumors? I would favor low-grade glioma, since maybe this is really the initial rationale. And we have now 2 patients, 1 in the previous study, another one here, took the treatment for a fairly long period of time. But we have to see. It's a matter of competition and strategy within the society. So this is it for Frivabrax. Then we move to the Metro SFC E01. So this was really here the very, very first metronomic trial that we launched in France for children. So when we go back, the idea was to have a multi-drug protocol, because we thought that these agents work differently, so we would likely increase activity or increase the target that we were able to reach with the treatment. The pediatric oncology community didn't want any temozolomide or etoposide because they were afraid of potential secondary leukemia, so we said no temo, no eto. We wanted the treatment to be mainly oral, and we wanted it to be multi-targeted. So basically we wanted depletion of Tregs that we thought we should have with the cyclophosphamide. We wanted also to have the maturation of dendritic cells, so that's why we had the vinblastine, which is only IV. And of course we wanted to be anti-angiogenic through different mechanism of action, which should be obtained with all the drug that we put in the regimen. So this is what we came up with. We have weekly injection of vinblastine. So the dose is lower than what we usually use in pediatric oncology, because we use 3 milligrams per meter square per week. Then we have non-stop COX inhibitor, and we have 3 weeks of low dose cyclophosphamide, and then alternating with twice weekly methotrexate. So it's like a colony regimen, but slightly modified because they're not together, but sequential. So this is the data about the pilot study that we did. And after the first patient, methotrexate, patient during the second phase tend to have mucositis, not mild, but still. So we lower the dosage of methotrexate. And then 2 of the patients that during the beginning of the treatment clearly clinically responded started progressing during the break. So we initially had a 2-week break, so we added this 2 weeks, additional 2 weeks of cyclophosphamide and another injection at week 7 of vinblastine, so that the break will be shorter and with and actually no breaks at all if you keep the cyclophosphamide. So this is the patient that were initially treated. As you see, most of them had progressive therapy, but in our mind, metronomic should be or could be a good option as a maintenance. So we also included patients that were really very likely going to relapse. So this is, as you see, they were previously heavily treated, lots of lines of treatment before for most of them. Like a third of them had received high-dose chemotherapy. Most of them had received previous radiotherapy. And the interesting point is that some of them are also received as a palliative line of treatment, metronomic chemotherapy with different protocol, the toposide, the combat protocol from Yaroslav, and the classical now, for at least in Europe, navalbine cyclophosphamide for rhabdomyosarcoma. And so as you can see here, for all of these patients, the time on treatment, on metronomic treatment was longer, at least the same as the previous line of treatment, even if it was metronomic. It suggests that there's not necessarily cross resistance between the different metronomic regimen. And some of the patients received the treatment for a fairly long period of time. And most of the time, the best result was stability, and we didn't get many responses. Toxicity was okay. We had some grade 3, we had some grade 4, but this is because those patients were really previously highly treated, and most of these grade 3 and grade 4 toxicities occurred in the patient who previously received high-dose chemotherapy, but still they could receive the treatment. So based on this preliminary finding, we decided to go for a state-of-the-art phase 2 trial using the same regimen for relapsing and refractory pediatric solid tumors. So patient had to have a measurable disease. We decided to not try to give the treatment to kids below 3 years old, because that's lots of pill to swallow every day for potentially a long period of time. So compliance may be an issue. And we stopped at 18 years old. We initially opened 10 centers in France, and then 3 other centers that they were interested. So we opened them. They not necessarily recruit patients, but so, and the primary endpoint was EFS after 2 cycles, which is 6 weeks. We had a small ancillary study to see if some angiogenic biomarkers could help us select the patient. But we don't have any immune biomarkers in this study. So the design was a very classical Kapner-Cheng 2-step model. So we had different cohorts of patients, you see. So basically, depending on how good we were doing in the different cohorts, that would be between 60 to 108 patients. So basically, this is how it works. You recruit 10 patients in a given cohort. If 2 or more patients reach the endpoints, if less than 2 patients reach the endpoint, the cohort is closed and this regimen has no activity in this disease. And if 2 or more patients reach the endpoint, you recruit 8 additional patients. And after the second stage, if the primary objective is reaching more than 6 patients, then the treatment is considered efficacious. So these are the 6 cohorts. The first one was ependymoma, because in the metronomic trial published by Mark, ependymoma were doing really good. We also had a neuroblastoma cohort, a bone sarcoma cohort, but Ewing sarcoma and osteosarcoma, a soft tissue sarcoma cohort, and then like a mixture of brain and non-brain tumors. And we started the recruitment in January, now 5 years ago. So this is basically what happened in bone sarcoma, nothing at all. So the thing is that we had very little Ewing sarcoma, in which the combination seemed very better. We only had osteosarcoma, and as far as I know, osteosarcoma, we know now they're not good candidate when they're progressing for metronomic chemotherapy. Maintenance may be a different issue, but I've never seen many patients responding or being stabilized by metronomic chemotherapy, so maybe we can share our respective experience on this point. In the ependymoma cohorts, 8 patients have been recruited. There was only 1 patient with stabilized disease after 2 cycles. And so because of a slow recruitment and the seemingly no activity, we decided to stop inclusion in this cohort of patients. In neuroblastoma, there were 16 patients included. We passed the first stage, And we had 4 stable patients after 2 cycles, but then we had this European trial that opened with standard dose chemotherapy plus or minus Avastin, and so everybody would go for Avastin. And so we had basically no patient at all. So we said, okay, let's stop. We're wasting our time. In the soft tissue sarcoma, we recruited 10 patients. 7 only were available for tumor response. We had two sterilized disease, and this is interesting. One in metastatic angiosarcoma, we had a minor response. And it was stable for 12 months, which is pretty much what you can find in literature, where metronomic chemotherapy seems to be a good option for this patient. Shripad and Eddie talked about also the combination with propanolol and metronomic. So there's something here, I think, to work on. And we had another patient with a metastatic endothelioma, bones, lungs, liver, really heavy disseminated disease that progressed after standard chemo plus Avastin. And so she's been stable for 2 years, and then we stopped the treatment. She remained stable for another year, and we decided to resume the same treatment, and she's being stabilized again with the very same treatment. Quality of life is perfect. She has now completed the nurse school. And she's happy. She has a boyfriend, so for her at least it was really a nice option. And our biggest disappointment is that we thought that would be a good option for children with rhabdomyosarcoma, because we know that metronomic cyclophosphamide nevelbine works greatly, but actually no one would put their patient that failed after vinorelbine on a and cyclophosphamide on a trial that has cyclophosphamide and vinblastine. So that's a missed opportunity, clearly. And in the non-brain group, we recruited 9 patients, and we had a very good partial response in a patient with a carcinoma long-lasting. So this is a little story. So this is a 4.5-year-old boy. We had a retroparotid mass with lymph nodes. So, we seek for advice all over the world regarding the diagnosis. That was really tricky. So we ended up with this diagnosis of myoepithelial carcinoma. It's the first time I see that kind of tumor in my life. And so we received several lines of treatment, but we didn't get much results. So at the end of the day, we performed surgery, radiotherapy, and it was in complete remission. But 1 year later, he had a multifocal metastatic relapse. So we put on what I call MGHE007, a multi-targetinib, and we managed to get a complete response in several months with a really, really good quality of life. Oops. I don't know which day. Oh well, I can't launch the video, too bad. Can you do it from there? So here's the little guy. So we thought that multi-targetinib is supposed to work on thrombin spawning 1, supposed to work to be a Treg depleter, and also it can make dendritic cell, induce dendritic cell maturation. And so with Eddie, we thought we were about to get rich, but of course it's not. It's not a multi-targetinib, but that's the regimen. So I guess it's also part of the message. Is like, if it was a fancy new molecule, everybody would be excited about this case, but it's only metronomic. We don't know how it works, so nobody will know about it unless you. This is, I guess, the most interesting part of the trial, although this is not something that we anticipated. The brain tumor groups, so we had more than 2 stabilized diseases after the evaluation of the first 10 patients, so we passed the phase 1. And the interesting thing is that actually we thought we would have aggregliomas, medulloblastoma in this group, but we ended up having low-grade glioma instead of having them in Fluvabex. We had them here, so that's the. And we had 3 patients with stable disease. And so we checked with the statistician and we said, can we have the extension cohort only for low-grade glioma, and can we still reach something that would be statistically meaningful? And so at the end of the day, we had 12 low-grade gliomas. The median age was 9 years old. So this might change because the database has not been, checked, 100% checked, and some of the data are still missing, but globally, this is the message. So they've been on treatment for 6 years when starting this trial. 7 previously received vinblastine, and I think 5 out of them just progressed under vinblastine. And we had 9 partial response, and we had 9 patients with 2 partial response and 7 stabilized disease for more than 2 cycles. 5 patients received the treatment for more than a year, and treatment was stopped for toxicity in 1 patient, but after several months because of the PEI decision, because they say, well, maybe that's enough now in 2 patients, and because of progression in 2 patients. And 8 of these patients are alive. I don't have all the data regarding the very life status. So it seems to be really something interesting for patients with low-grade glioma, even after receiving single-agent vinblastine. We also had 2 medulloblastoma, nothing much happened, and we had 4 high-grade glioma, including 2 DIPG, and we had 1 patient with anaplastic oligodendroglioma that had a stable disease for over 2 years, which is quite good. We did some experiments on the biomarkers, circulating endothelial cells and progenitors. Nothing much happened except for the comparison between progression and the previous dosage in the patient. So maybe, basically when the patient progressed, you get an increase in CC, which is not really helpful. And we basically already know. And so the last study I wanted to talk about is the Metro SF002. So it's a project that is based on our previous work. So if you want to know more about how beta blockers can impact on all the steps of cancer, I suggest you should go in and see that very nice review. We generated some pediatric data with Eddie on neuroblastoma. He tested like 7 agents and 10 anti-cancer agents and 7 anti-beta blockers on cell lines. We selected the best, seemingly combination, and ended up testing them in vivo. And we had the same results that when we combined these beta blockers with chemotherapy, here vincristine, we were able to prolong the survival of the mice significantly. So based on the results and other stuff that we had, we decided to go for a phase 1 trial in France. So this is going to be a phase 1 rolling 6 design. This was made with the collaboration of Pierre Fabre. So we have 3 levels of navalbine. We want to go for metronomic navalbine. Usually it's given once a week. And in the adults, especially in breast cancer, it seems that the metronomic dosage is less toxic. Can't say it has more clinical activity, but it's at least less toxic. So we're going for navalbine, metronomic navalbine. So we are going to have a single agent cycle to have the data with navalbine only, and then after the second cycle, we'll add beta blockers, and with a standard dose, which is somehow the one that works in hemangiomas, which is 1.5 milligram per kilo. And so Pierre Fabre agreed to give the medication of both navalbine and also the new oral formulation of propranolol, which is going to be very nice for the youngest patient. And then when we have the right dose, we'll have 4 cohorts of patients, neuroblastoma, and we had a trial about navalbine neuroblastoma that almost reached significant activity, so it was limited, but there's some activity. So we think that combined with propranolol could make the difference, and also changing the schedule. 1 cohort with Ewing sarcoma, 1 with rhabdomyosarcoma, sarcoma, and 1 just any tumors. So basically, metronomics, our experience, we also have, we participate to other European trials. So Mark is going to talk about the MEMA trial. There are several randomized trials investigating the role of maintenance, for instance, in rhabdomyosarcoma. So there are other stuff, but I didn't have time to talk about them today. But basically, oral metronomic chemotherapy has a fairly good toxicity profile. It can have some clinical activity. It's getting clear that it's not one standard regimen that will work for everyone, so we have to learn which drug to give to which disease. We have also to optimize the setting. This was just for relapsing, or refractory disease, but maybe as a maintenance for very high-risk patient could be a way forward. And we have to know to optimize combination dose schedule, include drug repositioning, include combine it with immunotherapy. The clearly way to combine it with anti-PD-1 and all these agents, and also combine with targeted therapy. I guess if we have a metronomic backbone that has some general activity, it may be also have a broad activity, because if you use target therapy, a single mutation can ruin the whole treatment. So they could match well, and since metronomic is well tolerated and not very toxic, overall you get a fairly doable regimen. And then, of course, I think we should move to personalized metronomics by using biomarkers. PK, of course, we just likely don't use PK enough, and of course molecular biology, and this is in line with what Giselle kind of showed yesterday, and we have to include drug repositioning and metronomic drugs in our portfolio. That's it. Thank you for your attention.